On June 26, 2020, at 12 a.m. GMT, a CoSpace Rescue Challenge map was issued to iCooL participants from around the world. All participants were given 24 hours to develop AI strategies to solve the same challenge. In CoSpace Rescue Challenge, teams are required to build a real robot, develop and program appropriate algorithms and strategies for both real and virtual autonomous robots to navigate through both real and virtual worlds. Additionally, they have to search and collect objects while competing with another team's robot that is also searching and collecting objects in the same real and virtual worlds. During the challenge, the robot needs to overcome barriers, avoid traps, and swamps. If the robot successfully makes a deposit, the points of the objects deposited will be doubled. For University and U19 category, the CoSpace server will send the robot its own coordinates while the robot is searching in the virtual world. The location information can be used for the development of AI algorithms and strategy such as path planning and search algorithms. Additionally, for University and U19 categories, there are signal block zones which are surrounded by pink dotted lines. When a robot enters the signal block zone, its coordinates information will be blocked. The winner of the challenge will be the robot with the highest points.
Hello, I am Mohammed Hani from Cairo, Egypt. I am one of the participants that successfully made it into the finals of the iCooL 2020 online challenge. I was in the RCAP CoSpace Rescue Challenge, the U19 category. I am very happy to be a part of this amazing community, and I had lots of fun in this online challenge. I have been involved in robotics for about 2 to 3 years. I participated in 2 RoboCup national competitions in Egypt. My strategy for programming the robot for this online challenge was that I first programmed the robot to do the basic things like moving around the map while avoiding obstacles, avoiding traps, collecting objects, and also depositing the objects in the deposit boxes. Then I made a search and navigation algorithm for the robot with certain priorities. The highest priority was for the robot to go to the super and super plus objects. Then priority below this was for the robot to go to the deposit boxes. Below this priority was for the robot to go to the black objects, then cyan objects, then red objects was the lowest priority. This is done using the robot's X and Y position and the compass on the robot. I also made the robot focus on collecting the objects in sets of red, cyan, and black in order for the super objects to spawn. This is done using some variables I created, and that is my strategy. Thanks for this amazing challenge, and I hope for more challenges like this in the future. Goodbye.
I am Ivan from the School of Science and Technology, and I am participating in the CoSpace Rescue U19 category. I have been involved in robotics for roughly 3 years now, since I was secondary 1. During the competition, the strategy I used for programming the robot was to make the robot go in a certain direction, and upon reaching a wall, turn right 90 degrees and head in that direction. This ensured that the robot picks up the most amount of points before returning to the delivery zone. I specifically coded the robot to avoid the corners, especially the top left and right corners of the field, as despite there being an increased amount of pickups there, it often resulted in the robot getting stuck in a corner. As such, avoiding it entirely allows me to spend the time more usefully to obtain other pickups and deliver them. Throughout the CoSpace learning experience, I faced many challenges. As I was new to the competition, the first challenge I faced was understanding the programming language. After a lot of trial and error and teaching from my peers, I managed to have a decent grasp on the language, allowing me to properly program the robot. When programming the robot, I realized that the robot easily got stuck or flipped over, causing me to code the robot to move more cautiously in my code. When the robot regularly got stuck in a specific place, I would program the robot to avoid the region entirely to save time. In the end, I managed to overcome these problems and produce a product which allowed me to enter the finals. I am extremely grateful to my school and my school's robotics club for allowing me the opportunity to participate in this event, as well as to my peers and teachers who helped me along the way.
And off we go! In this demo game, we will minimize any manual intervention. Red robot is in the swamp. Speed is restricted. Blue robot is depositing. Red robot is in the swamp. Speed is restricted. Red robot has a set of red, black, and cyan objects. It can generate a super object. Blue robot is depositing. Red robot is full. Red robot needs to make a deposit before it can continue collecting. Red robot is depositing. Red robot is depositing. Blue robot picks up super object. That's 90 points. Red robot travels out of the boundary. System resets it back to the field and freezes it for 10 seconds. Blue robot is depositing. Red robot is in the swamp. Speed is restricted. Blue robot has entered the black object area, and the black object is worth 20 points. Red robot is in the swamp. Speed is restricted. Red robot is depositing. Red robot is searching in the blue special area. Any objects picked up in this area will double in value. One minute left. Blue robot is leading. Red robot is full. Red robot needs to make a deposit before it can continue collecting. Blue robot is depositing. Blue robot wins this challenge. Congratulations!